Hello everyone, welcome to this video on Apache Kafka. In this session, we'll explore essential Kafka concept for basic to mid-levels interviews. This is part 1 of the two-part series where the next video will focus on advanced topics for experienced professionals. So without wasting time, let's start the video.
So the very basic question is, what is Apache Kafka? So Kafka is a messaging system based on the publish subscriber model, where there's one producer that send data streams to Kafka brokers and consumers that read and process the data from the broker. So it is mainly used to build real-time streaming data pipelines and applications. Next is, what are the key components of Kafka? So this is the architecture of Kafka, where we have producers, topics, partitions, brokers, consumer, and zookeepers. So what are producers? Entities that send messages to Kafka topics. And what are topics? Topics are logical channel to organize data. Partition for scalability. So, for example, a topic name user signups might be used to store and distribute events related to user registration. Then we have partitions. What are partitions? These are the subdivisions of topics for horizontal scaling and parallelism. Now, suppose a topic user signups may have three partitions, P0, P1 and P2. Now, what are these partition used for? They enable scalability and ensure messages can be processed in parallel by consumers. Then we have brokers. What are broker? Broker are actually the server. This is the server that stores and processes the messages. Consumers, entities that reads messages from Kafka topics. We'll see the difference between this consumer and consumer groups in future questions. This entire Kafka is managed by Zookeeper, which is a coordination service used by Kafka for configuration management, leader election, and failure recovery. So how does this Kafka works actually? The producer write to a topic, producer send data to a specific topic. Optionally, they can specify a key to determine the partition for the message. That means to which partition the message should go. Consumer reads from a topic. These consumers subscribe to the topic to receive data. And message within a partition are delivered in order. That means in a sequential manner. Topics are multi-subscriber, where multiple consumer or consumer group can subscribe to the same topic, and each consumer group gets its own copy of the data. Next question is, how does Kafka ensure durability and fault tolerance? Kafka does it using replication. Now in replication, each topic is divided into partitions. And every partition has a configurable number of replicas determined by the replication factor. So if the replication factor is 3, there will be one leader replica and two follower replicas. Now the role of this replicas are, the leader replica handles all read and write requests for a partition, and the follower replica replicates the data from the leader. In the event of a leader failure, one of the follower is promoted to leader. So if a broker hosting a replica fails, the replica of other broker ensures that no data is lost and operation can continue. They ensure fault tolerance and durability. Next is leader election. So Kafka ensure continuous availability through dynamic leader election. When a topic is created, Kafka assigns one replica as a leader for each partition. Now, this leader is responsible for coordinating read and write for that partition. If the leader fails, a new leader is elected from the ICSR. Now, what is ISR? ISR stands for in sync replica. So, Kafka track replicas that are fully synchronized with the leader. These are known as in sync replicas. Only data acknowledged by all replica in the ISR is considered durable. So this process is automatic. This ISR process is automatic and ensures minimal disruption. Now, a special broker called the controller manages the election of partitions leader across the cluster. If the controller itself fails, another broker takes over as the new controller. Next is persistent storage. Now, Kafka prioritizes durability by persisting messages to disk. Kafka retains message for a configurable duration on size even after consumer have read them. Next question is, what is the difference between consumer and consumer group in Kafka? Now, you can have independent consumers, they are not in groups, else you can have many consumer in one group. So the difference is a consumer is an application or process that subscribe to one or more Kafka topic and process messages from these topic. A single consumer is responsible for reading messages from one or more partitions of a topic. And a consumer group is a group of consumers that collectively subscribe to one or more Kafka topic. The group ensures distributed and parallel consumption of messages. So, each consumer in a group is assigned partition from the subscribed topic. Kafka guarantees that each partition is consumed by only one consumer in the group. So the most important difference is if you have independent consumer, they can read from all the partitions. But if there is a consumer groups with many consumer, different partitions are assigned to these consumers in the group. One consumer cannot read from partitions assigned to another consumer. So let's explain this with an example that a topic with four partition and four consumers, independent consumers. If this is the case, all four consumer can read from all partitions simultaneously, potentially duplicating message processing. But if you have four partition and four consumer in a same group, then Kafka assign one partition to each consumers. Messages in each partition are processed by exactly one consumer in the group. So in the group, no two consumer will read from the same partition. But this constraint is not in case of independent consumers. So this is the main difference between them. So when do we use single consumer? If you have only one instance of your application consuming message, it's a single consumer suitable for very simple use cases where scalability is not needed. But if you need to scale your application for higher throughput dependency, it is ideal for distributed system where multiple instances of an application consume message collaboratively. Next is what is rebalancing in Kafka? So in Apache Kafka, rebalancing is a process of redistributing topic partition among consumer in a consumer group whenever there is a change in the group. Example, a consumer joins. So if a new consumer joins in a group, it increases the total number of consumer. So Kafka reassign partition to distribute the workload across the new set of consumer. So uh, next is if consumer leaves or fails. So if one consumer leaves or fail, its assigned partition need to be reassigned to the remaining consumers who were idle. Other thing is if the topic changes. So new partitions are added to the topic, triggering a redistribution of partition among consumers. So rebalancing ensure that each partition is assigned to exactly one consumer in the group, maintaining an even distribution for efficient and fault tolerant processing. Next is what do you mean by retention policy in Kafka? So in Kafka, retention policies define how long messages are stored in a topic before being deleted. It's crucial for managing disk spaces and ensuring data freshness. So there are two types of retention policy, time-based retention and size-based retentions. So in time-based retention, messages are retained for a specific duration. So by default, it's 7 days. So once the retention period expires, then messages are deleted from your disk space. You can configure you can change the configuration using log.retention.hours or log.retention.ms millisecond. Then you have size-based retention. So messages are retained until the topic reaches a specific size limit. You need to mention the limit. As it reaches the threshold, your old messages will get deleted from the disk. So once the limit is reached, older messages are deleted to make space for new ones. This is configured using retention.bytes, where you can do all these configuration. So you can configure retention policies in Kafka in two levels, either in broker level or in topic level. Now in broker level configuration, there is a file called server.properties where there are all the global configuration setting for all topics on the Kafka cluster. You can set default retention parameters here, which will be applied to new topics unless overridden at the topic level. So what are the commonly used properties? Log.retention.hours and log.retention.bytes for time-based configuration and size-based configuration. You can do this configuration also in topic level. So where you will do that in Kafka topics.sh or the script file, where will allow the script allows you to modify the configuration of existing topic including retention setting. Now you should keep in mind that in both this type of configuration, topic level setting overrides broker level setting. So if you are doing the settings in both broker level and topic level, then priority will be given to the topic level settings. Next is, what is offset number in Kafka? So in Kafka, an offset is a unique identifier that represents the position of a message within a specific partition. It's essentially a numeric value that indicates the order of the message from the beginning of that partition. Offset numbers are sequence number. So first, if first message is 0, the next would be 1, the next would be 2. This way it works. Now, the last question is, how does a new consumer know where to start after partition reassignment in Kafka? So for example, if one consumer fails and the next consumer is assigned that partition, the partition of the failed consumer, so the older one was processing some message. So the new consumer, how it will know that from which message it should start now? This is done using a mechanism called consumer offset to track the progress of each consumer within a consumer group. So these offsets, which we have discussed in the previous question, are essentially pointers to the next message that a consumer should process in a particular partition. So how does it work? Offset commits. When a consumer successfully processes a message, it commits the offset of that message in a special topic. So there is a special topic for keeping all the offset information called the consumer underscore offsets. This topic is internal to Kafka and it is used to store the offset for all consumer groups. Now, if the consumer fails or is removed from the group, the Kafka cluster triggers a rebalance. During the rebalance, the remaining consumer in the group are assigned new partition. So, when a new consumer is assigned a partition, it fetches the latest committed offset for that partition from the consumer offset topic. This offset indicates the next message that the new consumer should process. So this way the new consumer will know from where it needs to start. So that's for this video on Kafka Basic for interview preparation. I hope this session helped you to understand the core concept. Stay tuned for part 2 where we'll explore more advanced topic for experienced professional. And please don't forget to like, subscribe and hit the notification bell to stay updated. If you have any questions or suggestions, feel free to drop them in the comment below. Thank you for watching and I'll see you in the next video. Thank you.